Topic: Construction processes. At the end of this lesson you should be able to understand the following concepts. MIG welding. Advanced welds and their application. Overhead welding. Vertical upward welding. Pipe welding. Cast iron welding. Building up of worn parts. Shrinkage of welds. Oxyacetylene cutting. Plasma cutting. Introduction. Learning content that was covered in Grade 11 and Term 1 Grade 12 must link in with the current content that will now be covered. Grade 10 Welding, arc welding, safety and workshop practices. Grade 11 Welding, arc welding, oxyacetylene welding. Grade 12 Workshop safety. The purpose of this lesson is to discuss content associated with MIG welding, advanced welding. Advanced welding processes, oxyacetylene cutting and plasma cutting. Concepts and skills. MIG, metal inert gas welding. What is MIG welding? MIG welding was developed in the 1940s and 60 years later the general principle is still very much the same. MIG welding uses an arc of electricity to create a short circuit between a closely fed anode plus the wire-line nozzle end. A cathode, the metal being welded. The heat generated by the short circuit, together with a non-reactive, inactive gas melts the metal locally and allows them to mix. Once the heat is removed, the metal begins to cool and solidify, forming a new piece of fused metal. MIG welding is useful because you can use it to weld a wide variety and types of metals: carbon steel, stainless steel, aluminum, magnesium, copper, nickel, silicon, bronze, and other metals. MIG machine parts. Task: name the parts in the photo below of the MIG welding machine as numbered from A to H. What is MIG welding about? It is an arc welding process in which separate recordings electrodes, standard welding rods, are displaced by continuous line wire and loss inlet gas screen replace the electrode current, electrode flux. The welding machine. Inside the welding machine you will flush a MIG wire and see a series of rollers that eject wire to the nozzle. There is not much going on inside this part of the welding machine, so it is worth spending just a minute to familiarize yourself with the different parts. If the wire feed is blocked for any reason you will want to look at this part of the machine. On larger MIG welding machines, the wire feed unit will be able to be separate as in the photos below. The large spool of wire must be held in place with a tension nut. The nut should be tight enough to prevent the spool from unraveling and thus avoid overrunning bird's nest. When the trigger is released, but not so tight that the rollers cannot pull the wire from the spool. If you can follow the wire from the spool you will see that it goes in a series of rollers that pull the wire from the large roll. It then pushes the wire to the nozzle point ready for welding. Gases used: argon, helium, carbon dioxide, CO2. CO2 or a mixture of CO2/argon can be used to weld medium steel. Gas supply. When you use a shielding gas with your MIG welding machine there will be a cylinder gas behind the MIG. It is either 100% argon or a mixture of CO2 and argon. This gas protects the weld as it forms. Without the gas, your welds will be browned, splashed and generally will not look very pretty. Open the main valve of the cylinder and make sure there is gas in it. Your meters should read between 0 and 2500 psi in the tank and the regulator should be set between 15 and 25 psi depending on how you want to set it and the type of burner you are using. When welding in areas with a pool, the gas pressure must be increased to prevent porosity of the weld. Once the wire moves through the rollers, it is guided through a set of pipes to the welding nozzle. The pipe carries the charged electrode and the argon gas. The welding nozzle/welding gun. The welding gun is the business of everything. This is where most of your attention will be focused during the welding process. The MIG welding gun consists of a trigger that controls the feed of the wire and electricity. The wire is guided by a replaceable copper tip made for each specific welding machine. The copper tips vary in size to suit the diameter of the wire you are welding with. This part of the welding machine will most likely already be set up for you. The outside of the tip of the welding nozzle is covered by a metal sheet that protects the electrode and directs the gas flow to the tip of the cutting nozzle. The earth clamp. The earth clamp is the cathode in the circuit and completes the circuit between the welding machine and the project. It must either be attached directly to the piece of metal being welded or attached to the metal welding table, such as the one pictured below. For the welding machine to work, the earth clamp must make good contact with the piece being welded. So make sure you sand away any rust or paint that could prevent the earth clamp from making contact with the workpiece. Safety equipment. The light generated by any form of arc welding is very bright. It will burn your eyes and your skin just like the sun if you do not protect yourself. The first thing you will need to weld is a welding helmet. Wear gloves and leather to protect yourself from molten metal splashing away from your workpiece. Some people prefer thin gloves for welding so you can have much better control. If you do not intend to wear leather, at least wear clothes made of cotton. Do not wear patches or synthetic shoes with gauze over the front of your toes. Hot metal often falls straight down and can burn holes through the top of your shoes. Weld in a well-ventilated area. Welding produces dangerous fumes that you should not inhale if you can avoid them. Wear either a mask or a respirator if you are going to be welding for a long time. Security warning. Do not weld galvanized steel. Galvanized steel contains a zinc layer and releases a toxic gas when burned. The gas causes cancer. Exposure to the gases can lead to heavy metal poisoning, welding chills. Symptoms such as flu can persist for several days, but it can also cause permanent damage. Fire. Molten metal can splash a few feet from a weld. Sparks are even worse. Any sawdust, paper or plastic bags in the area can smolder and burn, so maintain a neat environment when welding. Your attention will be focused on welding and it will be difficult to see what is going on around you if something catches fire. Advantages. High welding speed / faster. Significant savings in materials and weight. High mechanical properties of welded joints. Neat and smooth node surfaces. Guaranteed welding strength for base and low welding. Safety against cold slits and cracks. Welding in all positions, vertically up, down and overhead. The ability to weld a wide range of metals and thicknesses. Ability to be used in all welding positions. A good welding pool / bead. A minimum of welding splashes. Easy to learn. Does not burn easily. Excellent fusion and penetration. The job requires less manual dexterity. Welding areas are easier to see. No heavy welding slag to control or chop away, gas under pressure will seal the welding pool. Potentially cheaper. Weld a wider field of thicknesses. Welding wire rolls off a coil and does not need to be replaced regularly. Disadvantages. MIG welding can only be used on thin to medium thick metals. The use of an inert gas makes this type of welding less portable than arc welding, which does not require an external source of shielding gas. Welding cable length limited. Produces a less controlled weld as compared to TIG, tungsten inert gas welding. Welding cable cannot bend sharply, wire breaks. What are the correct settings? If you experience holes in your work, your power setting is too high, and you are melting through your weld. If your welding is uneven, your wire speed or power settings are too low. You will know when the settings are right, your weld will look nice and smooth. The quality of the weld also depends a lot on the sound of the welding process. You want to hear a continuous sparkling sound. Some welding operators say it sounds like an egg baking. MIG wire welding problem / wire attached to the tip. Sometimes when you weld too close to your material or you build up too much heat, the filler wire at the front of the weld nozzle can burn to the tip. It looks like a small piece of metal on the tip of your nozzle, and you will know when you have this problem because the wire will not come loose from the nozzle. Fixing this problem is pretty simple. You just pull on the piece of metal with pliers. Advanced welds and their application. Name the welds below and find out where each can be used. Overhead welding. Overhead gas welding requires a reduced melting pool, large enough to create the desired penetration. Done by reducing the size of the flame, or the use of a slightly thicker welding rod. Power of the flame will help you hold the molten metal in position. Overhead arc welding. Use a bow as short as possible. Weld a number of runs without any sideways movement. When molten metal begins to drip, the amperage should be slightly reduced. Move electrode slightly faster. Hold electrode in the same position as in relation to base metal. Vertical upward arc welding. Welding upwards in a vertical position can be a problem because the molten metal of the welding coil tends to run down or drip. Special electrodes are used for vertical upward welding with an arc welding machine. This makes the process easier because it freezes faster. Ampere can be slightly lowered from the normal manual setting. Point of the electrode should point upwards so that the electrode makes an angle of up to 30 degrees with the horizontal plane. Arc should be short and the speed just enough to prevent the molten metal pool from running down. When welding upwards, very few lateral movements of the electrode must be made. Different types of welding movements. Figure 8 run. U-run. Zigzag run. Triangular run. Pipe welding positions. Horizontal fixed position. The pipe rests on rollers or a suitable surface that allows the pipe to rotate evenly in one direction while the welding process is in progress. The welder holds the electrode in a constant position while the pipe moves. Horizontal moving position. The pipe is in a fixed position and the welder follows the load where welding is required. Vertical position. The pipe is in a vertical position and the welder follows the load by welding it in a left or right direction. Tilted position, oblique, the pipe is mounted obliquely and the welder welds the load left or right. Cast iron welding. Use an pure nickel welding rod. The amperes should be as low as possible. The arc should be slightly longer than for welding mild steel. Before starting the welding process, make sure that all rust, grease, dirt or any other object that could weaken the load has been removed. Remember to remove the surface layer of the metal where the weld is made. Cover the suspected area with white chalk. Vaseline in the cracks, it will make white chalk gray or show a wet line. Mark the line with a punch and hammer to prevent the line from disappearing if you weigh it out V-groove. It is very important that the casting is kept as cool as possible by the welding process. Preheating a casting that needs to be welded can help prevent the formation of new cracks. Cast iron should be allowed to cool very slowly after being welded. Cast iron should never be placed in water to cool. While allowing a weld to cool, it can be tapped lightly with a small hammer. This action helps to relieve the tension around the weld. What to keep in mind after you have finished welding. Gravity can cause the metal to drop or run off. Keep the space small. Prevent overpenetration and burnout. Electrode size plays a role in the welding process. The current plays a dominant role in the welding process. Surface must be thoroughly cleaned. Building up of worn parts. Hard facing. It is the process by which worn parts can be built up by filling them in. The type of hard facing and type of electrode used is determined by the need for the specific parts. The area to be covered should be free of corrosion, grease or foreign matter by grinding/sanding it away. Types of wear and tear. Metal to metal friction. Severe bumps or shocks of metal against stone. Scraping plus shocks or bumps. Severe scraping. Shrinkage of welds. Types of shrinkage. A. Longitudinal shrinking. B. Angular shrinking longitudinally. C. Angular shrinking. D. Lateral shrinking. Definition of shrinkage. When metal is heated it expands and when it cools, it shrinks. The shrinkage of the welded metal as well as welds cause distortion of plates as it cools. Shrinkage occurs simultaneously in all directions and thus causes several types of distortion. Factors that cause shrinkage. Amount of welding. Number of welding runs. Degree of resistance. Original state or condition of parts that must be welded. Welding procedure. Prevention of shrinkage. Admission for distortion by preposition. Welding of patchwork. Clamping. Point welding. Spot welding. Proper preparation of the weld is important. Short fast welding. Preheating. Spread the heat over the entire section. Limit the amount of welding runs. Oxyacetylene cutting. Task: name the different components of the oxyacetylene cutter. Cutting process. The heating flame must be a neutral flame setting. Hold the cutting edge perpendicular to the workpiece. The heating flame should be kept approximately 2 mm away from the workpiece. Hold the flame in this position until the workpiece is bright red hot. Now push the oxygen supply lever. Hold the lever and gradually move the cutting tip in the cutting direction. Do not rush into action. The metal must be allowed to heat as the cutting process proceeds. Be sure to cut the flame through the metal. Sparks and metal splashes will be visible at the bottom of the workpiece. Remember, the thinner the metal, the smaller the cutting edge should be. Thicker metals require larger cutting points. Types of metals that can be cut. Mild steel. Cast iron. Stainless steel. Use of an oxyacetylene apparatus for heating. The purpose of this process is to show you how to use an oxyacetylene device for heating to use. Wear leather apron or similar protective clothing and welding gloves when using an oxyacetylene nozzle, and always use proper welding goggles. Personal safety. When doing a task in the workshop, you must use personal protective clothing and equipment that is appropriate for the task and that complies with your local safety regulations and policies. This may include the following: workwear, such as overalls and steel-toe shoes. Eye protection, such as safety goggles and face masks. Hearing protection, such as earmuffs and earplugs. Hand protection, such as rubber gloves and protective cream. Respiratory equipment, such as face masks and valve respirators. Safety tips. Oxygen and acetylene cylinders must be stored safely and in an upright position. An oxyacetylene apparatus produces a large amount of heat. Be aware that any objects you aim the flame at will become hot. Always keep a suitable fire extinguisher near your work area. Do not use an oxyacetylene device near any flammable materials. Make sure you understand and adhere to all legislation and personal safety procedures when performing tasks. Step-by-step instructions. Ignite the cutting nozzle and adjust the gas flow until you have a neutral flame. Heat forge removal. Place a flywheel and ring gear on insulating spaces to elevate them above the work surface. Aim the flame at the ring gear until smoke appears. Stop the heat. At this point, the ring gear is hot enough to remove by lightly chopping it with a hammer and drift. Do not touch the metal with your hands. Use welding gloves and tools designed for use in a hot environment. Heat to red warm. Aim the flame at the component you want to heat. If the component is made of thin metal, it will heat up faster than one that is thicker. Apply the heat evenly until you see the object glow red. Once the glow is uniform, the metal is hot enough to manipulate. Do not touch the metal with your hands. Use welding gloves and tools designed for use in hot environments. Extinguish/shut down. When the work is done, you will need to shut down the equipment. Close the acetylene valve on the welding nozzle. This will extinguish the flame. Close the oxygen valve on the welding nozzle. Next, you remove your safety goggles or mask and your welding gloves. Turn the main valve to the top of both throttle cylinders clockwise. Now open the two valves on the cutting nozzle to bleed the system. Turn both the oxygen and acetylene regulator handles anti-clockwise until they are loose. Close both valves on the cutting nozzle. Replace the handle and tips and place the cylinders and pipes back in their own storage area. Plasma cutting. Plasma cutting, also known as plasma arc cutting, is a technology developed from the Second World War era. The process involves the use of a tungsten electrode and high-pressure plasma is gas in an ionized state to generate an electric arc between a copper nozzle and workpiece. It is the electric arc that does the cutting, but the high-pressure plasma helps to clean the cut by removing the debris, metal impurities, generated by the cutting. Low voltage, high current. The plasma cutter uses an electric transformer and internal circuitry to convert the supply voltage of 220 volts AC with a 15 amp current into a low voltage high current cutting current. The typical voltage range of the plasma cutter can be anything between 20 to 50 volts. The current on the other hand can have a high output of up to 100 amperes. It is this high current that causes the identifiable blue and white cut current of electric plasma. Electricity is carried on the outside of all electrical wires. It is the free electrons of copper, the most common wire to carry electricity, which carries or causes the force to move from one point to another. The plasma cutter with its unique circuit concentrates this electron flow in a stretching cutting current. The electrons form a plasma-like substance that can be seen when the trigger is pulled on the cutting handle. It is this intense plasma that heats the metal and melts in a small diameter pool. Compressed air. The final power. Once the molten pool is made, another force is required to push the pool through the other side of the material being cut. Compressed air, at the rate of 100 pounds per square inch (psi), is guided through the cutting nozzle and is released when the trigger is pulled. This plasma stream is now complete and creates a small diameter, fine line for cutting metal. Usually the plasma flow is so intense that the cutting nozzle can be moved along the surface of the metal at a speed of 250 centimeters or more per minute. Compared to other types of cutting devices, which can only reach a maximum speed of 75 centimeters per minute, it makes the plasma cutter a high-speed cutting device. The angle of the cut. A small disadvantage or physical property of the plasma cutter is the angle of the final cut with respect to the material. The plasma arc will cut a 6 to 7 degree angle on the vertical face of the material. Thin metal will not have a vivid viewing angle as opposed to thicker material. Metal with a thickness of 5 mm or thicker will need to be ground with an electric angle grinder in order to obtain a true perpendicular angle with respect to the horizontal surface. Plasma cutting, safety. One of the most important aspects of using a portable plasma cutting machine is safety. Although the operation of the machine is relatively simple, the power of the machine and the level of voltage it contains require that safety is a high priority. Refractory gloves and a face shield must be worn at all times. All plasma cutting machines are a potential fire hazard because they blow hot metal and sparks, so flame-retardant clothing should always be worn. Any flammable material should be at least 35 meters away from the machine while it is in operation. Very importantly, plasma cutting machines contain a potentially deadly voltage reserve. If any live electrical parts are touched, fatal shocks or serious burns will occur. Although the hand plasma cutting machine is easy to handle, certain errors can be fatal. Plasma cutters produce an intensely hot plasma jet that exceeds 45,000 degrees. Under no circumstances should the plasma cutting nozzle be contacted with any part of your body while the machine is in operation. Never touch the workpiece near the cutting area due to the risk of burns. When used for cutting metal, the plasma cutter causes large amounts of sparks and hot metal that can burn clothing or other flammable items around your workspace. Wear fire-resistant, insulated clothing and make sure the workplace is free of fire hazard. As a secondary effect, a plasma beam causes a large amount of visible, ultraviolet radiation which can be harmful to the eyes. Sparks and hot metal can cause eye injuries. Wear proper face and eye protection while using the plasma cutter. Appropriate eye protection will be further outlined in your safety manual. Cutting metal with a plasma cutter will generate dangerous gases. Wear proper breathing equipment, and do not inhale these gases under any circumstances. If you are inspecting an assignment when you have cut it, you should look at the assignment from the side end, not from above. Make sure the workplace is well ventilated. An exhaust hood or a space open to the outside is recommended when using the plasma cutting device. Use respirators or other breathing apparatus where necessary. Advantages: fast cutting speed, wide range of materials and thicknesses, easy to use, economic. Problems and disadvantages: the machine produces an arc and then loses it, or if the arc cannot penetrate the metal where it once could. Examine the consumable materials first. The electrode and contact point close/wear slightly with each start/. Stop cycle and must be replaced when they are excessively worn. Some of the biggest problems are related to air pressure. Low air pressure leads to poor performance, especially at high amperes. Look for this condition. Try to increase the pressure on the machine. If the pressure gauge does not move much further than the optimum setting, pressure on the gas source can be adjusted because minimum flow rate cannot deliver enough pressure in a few meters of pipe. To ensure sufficient pressure on the machine, the source gauge can be set a little higher than the pressure gauge on the machine. To ensure adequate air pressure for a plasma machine, use a gas pipe with at least a 10 mm internal diameter and fittings that match, or exceed, the rating recommended in the machine's manual. Many plasma cutters have a built-in regulator with an air filter, but a good practice is to install additional filters and separators on the gas supply to remove water or other contaminants.
Please like, share, and subscribe to the channel for more future educational videos.